In this lesson, we'll learn what a limit is and how to find a limit graphically. A limit is the value that a function approaches as the input approaches a particular number. The notation says, the limit of f of x, as x approaches c, equals L. This means that as x gets closer and closer to c, the function values get closer and closer to L. Let's find a limit graphically using an example. Consider the function f of x equals x cubed minus 1 divided by x minus 1. Although the formula cannot be evaluated exactly at x equals 1, we can still look at what the graph is doing nearby. First, let's move toward x equals 1 from the left. Now let's approach x equals 1 from the right. Notice that from both the left and the right, the graph approaches the value 3. Even though there is a hole at x equals 1, the limit still exists because the function approaches 3. Therefore, the limit as x approaches 1 is equal to 3. Sometimes a limit does not exist. Let's look at the three most common situations. The first situation happens when the left-hand limit and the right-hand limit are different. Approaching 0 from the left, the function approaches -1. Approaching from the right, the function approaches +1. Because the left and right limits are not equal, the limit does not exist. The second situation occurs when the graph grows without bound near the point. From both sides, the function increases without bound. It never approaches one finite value. Likewise, 1 over x cubed also has no limit. Notice that now the graph approaches -infinity from the left and +infinity from the right. The final situation occurs when the function oscillates forever as it approaches the point. Near 0, the graph oscillates faster and faster, never settling on a single value. Since the function never approaches one number, the limit does not exist. To summarize, a limit does not exist when the left and right limits disagree, when the function becomes unbounded, or when it oscillates without settling on a value.